Lightning, a sudden, dramatic release of energy. It illuminates the sky with its raw power, a true force of nature. For centuries, humans have gazed upon this celestial display with a mixture of awe and fear. Myths and legends arose around its unpredictable nature. We crafted stories of gods and monsters wielding the power of the sky. But what is lightning really? Beyond the myths and legends, it is a fascinating scientific phenomenon. Lightning is a powerful electrostatic discharge. This discharge occurs in the atmosphere, creating a bright flash of light. It is a reminder of the immense forces at play all around us. Lightning is a beautiful reminder of the power of nature. It is a stark demonstration of the forces that shape our planet. Understanding lightning allows us to appreciate the delicate balance that exists in the natural world. So let's delve into the science behind this electrifying phenomenon. To understand lightning, we must first journey into the heart of a thunderstorm. These storms are not just random occurrences. They are complex systems driven by the forces of nature. Towering cumulonimbus clouds, often called thunderclouds, are the birthplaces of these electrical giants. These clouds can reach heights of up to 12 miles, creating a dramatic and awe-inspiring sight in the sky. These clouds are colossal, stretching upwards for miles, their tops reaching the freezing heights of the atmosphere. At these altitudes, the temperature can drop to as low as 60 degrees Fahrenheit, creating the perfect conditions for the formation of ice crystals. Within these stormy giants, a chaotic ballet of ice and water particles unfolds. The constant movement and collision of these particles create a dynamic environment where energy is continuously exchanged. As updrafts and downdrafts collide within the cloud, tiny ice crystals are whipped about. These updrafts can reach speeds of over 100 miles per hour, lifting water droplets and ice particles high into the cloud. These collisions generate static electrical charges within the cloud. The friction between the particles causes electrons to be stripped away, creating areas of positive and negative charge. The cloud becomes a giant battery with different areas holding opposite charges. This separation of charge is a key factor in the development of lightning. Typically, a separation of charge develops. The upper part of the cloud becomes positively charged, while the lower part becomes negatively charged. Positively charged particles gather at the top of the cloud. These particles are usually smaller ice crystals that have lost electrons during collisions. Negatively charged particles accumulate in the middle and lower portions of the cloud. These are typically larger ice particles or water droplets that have gained electrons. This separation of charge creates an electric potential difference, similar to the voltage in a battery. The greater the separation, the higher the potential difference, and the more likely a lightning strike becomes. When this voltage becomes sufficiently large, it overwhelms the insulating capacity of the air. The air, normally a good insulator, can no longer hold back the electrical forces. The result? A sudden, dramatic discharge of energy, a lightning bolt. This powerful release of energy can heat the air to temperatures 5 times hotter than the surface of the sun, creating a brilliant flash of light and a thunderous sound. The most familiar type of lightning is cloud-to-ground lightning. This dramatic phenomenon is not just a simple flash in the sky, but a powerful display of nature's raw energy. While it appears as a single bolt, the process is actually a complex dance of electrical charges. This intricate ballet begins high up in the storm clouds, where the conditions are just right for lightning to form. The negatively charged region at the bottom of the cloud seeks a path to the positively charged ground below. This charge separation is crucial for the formation of lightning and is driven by the turbulent motions within the storm cloud. It does this by sending out a faint, negatively charged channel called a stepped leader. This leader is almost invisible to the naked eye, but plays a vital role in the lightning process. This leader zigzags downwards in a series of steps, searching for the path of least resistance. Each step is a small burst of energy, moving the leader closer to the ground. As the stepped leader approaches the ground, the positive charge on the ground becomes concentrated. This concentration of positive charge is often strongest on tall objects like trees, buildings, and even people. Objects like trees, buildings, and even the ground itself send out upward streamers of positive charge. These streamers reach up towards the descending stepped leader, eager to complete the electrical circuit. When the negatively charged stepped leader connects with a positively charged streamer, a circuit is completed. This connection is the moment of truth, where the potential energy stored in the cloud is about to be unleashed. This connection creates a path for a massive surge of electricity to flow. The energy released in this moment is immense, capable of heating the air to temperatures hotter than the surface of the sun. This surge, known as the return stroke, travels upwards at incredible speed. The return stroke is the most visible part of the lightning strike, and it is what we see as the bright flash of light. It is this return stroke that we perceive as the bright flash of a lightning bolt. The entire process, from the formation of the stepped leader to the return stroke, happens in a fraction of a second, yet it releases a tremendous amount of energy, illuminating the sky and often accompanied by the sound of thunder. Section 4. Furious energy. Temperature and the sound of thunder. Lightning is one of nature's most awe-inspiring phenomena, a powerful reminder of the raw energy that our planet can unleash. Lightning is not just a visual spectacle, it is a display of immense energy. Each bolt is a testament to the incredible forces at play in our atmosphere. The temperature of a lightning bolt can reach a staggering 50,000 degrees Fahrenheit. To put that into perspective, it's hotter than the surface of many stars. That's 5 times hotter than the surface of the sun. This extreme heat is generated in a fraction of a second, creating a plasma channel that cuts through the sky. This intense heat causes the air around the lightning bolt to rapidly expand. The sudden expansion of air creates a vacuum that is quickly filled, resulting in a shock wave. This rapid expansion creates a shock wave that we hear as thunder. The sound of thunder is a direct result of the violent displacement of air. The rumbling sound of thunder is caused by the sound waves echoing and bouncing off the ground, clouds, and other objects in the atmosphere. These echoes can create a rolling effect, making thunder seem to last longer. The distance between you and the lightning strike determines what kind of thunder you hear. The closer the strike, the sharper and louder the sound. A close strike sounds like a sharp crack, while a distant one rumbles and rolls. This variation is due to the time it takes for the sound waves to travel through the atmosphere. The immense energy released by lightning also has other effects. It can alter the chemical composition of the atmosphere and impact the environment in various ways. It can create nitrogen oxides in the atmosphere. These compounds are formed when the intense heat of the lightning bolt causes nitrogen and oxygen in the air to react. These oxides play a role in the nitrogen cycle, fertilizing plants but also contributing to air pollution. The nitrogen oxides are eventually washed down by rain, providing essential nutrients to the soil. Lightning can also start wildfires, igniting dry vegetation with its intense heat. These fires can spread rapidly, causing significant damage to ecosystems and human structures. The global impact of lightning is profound, influencing weather patterns, atmospheric chemistry, and even the evolution of life on Earth. Understanding this powerful force helps us appreciate the delicate balance of our planet's systems. Section 5. Lightning by the numbers. Fascinating facts and figures. Lightning is a phenomenon of staggering scale and frequency. Did you know that at any given moment, there are approximately 2,000 thunderstorms occurring around the world? These storms produce an estimated 44 flashes of lightning every second. Each of these flashes can be incredibly powerful, carrying an average current of 30,000 amperes. That's enough electricity to power a 100-watt light bulb for more than 3 months. The Empire State Building in New York City is struck by lightning an average of 25 times per year. The bright flash of lightning is not only due to the electrical discharge, but also to the superheating of the air. The air is heated so rapidly that it becomes incandescent, glowing brightly for a brief moment. This incredible brightness can illuminate the surrounding landscape with an eerie glow.